My name's Mia, and I'm going to show you how to do a flow rate problem. The problem that we have is the IV order reads 2,000 milliliters D5W with potassium chloride, 60 milliequivalents to run for 10 hours. The IV drip factor is 15 drops per milliliter. What is the flow rate? First, you want to do your formula of the amount times your drip factor divided by time. So the amount that we have is 2,000 milliliters. And then times our drip factor of 15 drops per milliliter. And then we need to divide that by the time of 10 hours. So you multiply across the top, which gives you 30,000 drops over 10 hours. You need to divide those, which gives you 3,000 drops per hour. But we need to know what it is per minute. So if we divide by 60 minutes, and it gets rid of the hour part, you end up with 50 drops a minute.
Hi, my name is Mathias. As far as me, I already showed you how to do this problem one way. I actually do it a little bit differently, so I'm going to go ahead and show you that. So we'll start out. So we have 2,000 milliliters. We're going to infuse it over 10 hours. So we're going to divide the 2,000 milliliters divided by the 10 hours, which gives you which gives you 200 milliliters per hour. Then to find the minutes on that, you're going to divide that by 60 minutes. So then the 200 milliliters divided by 60, that gives you 3.33 remainder. Okay, and then so we calculate in the jits, so we're going to times it by our drops of 15 jits per milliliter, and then that equals out to 50 jits per minute.
My name's Mia, and I'm going to show you how to do an infusion rate problem. The physician orders 250 milliliters of 0.9% normal saline to infuse over 2.5 hours. What is the milliliters per hour? So first you need to figure out what you have and what you need. So you know that you have 250 milliliters over 2.5 hours. And you need to know how much is infusing per hour. So 1 hour, and that becomes an X. You need to cross multiply, and then you divide. And this equals out to 100 milliliters per hour.
Alright, Mathias, once again here, I'm going to show you the problem that Mia did earlier, just a little different way. So you have 250 milliliters. We're going to infuse it over 2.5 hours. So So essentially, real quick way to do it, 250 milliliters divided by 2.5 hours, and that will give you 100 milliliters per hour.
Hi, my name is Nicole and I'm going to help you through this math problem. The question is, a client needs to take diflucan, 40 milligrams oral suspension. The drug comes in 40 milligrams per 5 milliliters. How many teaspoons will the client take per dose? We'll start by gathering what we have and what we need. What we have is 40 milligrams per 5 milliliters. And what we need is to figure out how many teaspoons for 40 milligrams. And when you have a problem like this, and you have the option to cancel out, you should do that before you continue, because 40 milligrams and 40 milligrams cancel each other out, leaving you with just this problem. 5 milliliters equal X. But you're not done because you need to know how many teaspoons the client will take. And in that case, you need to convert 5 milliliters to teaspoons, which 5 milliliters equals 1 teaspoon. The physician orders enalapril 0.0025 grams by mouth daily. Enalapril is available in 5 milligram scored tablets. How many tablets will you give? So I would start this by realizing we have 2 different units of measurement and trying to make them the same. I'm going to take 0.0025 grams and times it by 1,000 to get 2.5 milligrams. Now we're working with the same units of measure. So to solve the problem, you have 5 milligrams, and you need to know how many tablets you would take to get your physician's orders of 2.5 milligrams. So now we just cross multiply. So you have 5 times 1, which is 5, equals 2.5x. 5 times 1, 2.5 times x. So now we need to get this x by itself, and to do that we'll divide 2.5 out of each side of the equation, giving us 1/2 equals x. So this is your answer. You'll need 1/2 a tablet.